Hello, Python coders. We're going to take a look at chapter 4 just to wrap it up today, we hope. And this is a document at the very top of the Learn Here section in chapter 4, module 4. And as you can see, I've got the document open, and it's a good review. It's a good overview of the whole chapter, what's in chapter 4. And one of the things that's in there is while loops. There's two types of loops, while loops and for loops. While loops will continue to cycle as long as the while condition is true. The statements that are inside the loop will continue. Now, what puts them inside the loop? Indentation. Indentation determines what's inside the loop. Many programming languages use curly braces to show where a loop block starts and ends, but in Python, it's just indentation. Now you can have any number of statements inside that loop, but it could be one, or it could be hundreds, maybe even thousands in a more complex application. Loop might not run at all if the condition is false from the get-go. Let me just show you a really quick example of that. I'm going to fire up idle here. And as you can see, this is the, I've just installed the Pygame. That's why I'm getting that. Try that again. All right, there's what you get when you start up Python, as you know. So what I'll do is I'll just try entering, say, num equals 10. And now I'll try a while loop. Use the keyword while, and then you have an expression which is going to use relational operators. Now the relational operators, that's less than, greater than or equal to, less than or equal to, or not equal to. There's quite a few of them, but they're covered quite nicely in your textbook. There's a table showing them in your textbook. So I could say while num is less than 10, colon. This is what we would call a Boolean expression. It's got a Boolean relational operator, and then it's got something on both sides of that operator. Well, let's see what happens here if I press enter, and maybe what I'll do is I'll print hello inside this loop. So we can get the case right here. Okay, and let's see what we get. Nothing. Crickets. No output at all, because this condition was false from the get-go, wasn't it? Num is not less than 10. Num is equal to 10. So because this evaluated as false, the loop is skipped entirely. So that's one thing about a while loop. It might not ever start. If the condition is false from the get-go, the loop doesn't run. Okay, now if I modify this a little bit, I could go up to this line. You can cursor up to this line or click there with my mouse. I'll try a different value for num. I'll try num equals 5. And then I'll try to repeat these statements up here by pressing enter. And now it's running. But here's another thing about while loops that you got to be careful of. I've got an endless loop. You can see at the very bottom, see it flashing. It's printing hello endlessly. It's an infinite loop. So that's always a danger. In order to fix something like that, you have to modify the loop. You have to add an extra statement inside the loop that'll eventually make the loop condition evaluate as false to stop the loop. Okay, this is why we call it a pretest loop. You can see why we call it a pretest loop. It might not start at all. And the danger is the endless loop situation. I guess I killed that window right off, unfortunately. Really wasn't finished with it, so we'll start that again. Let's try num equals just 1 this time. And we'll try while num is less than 10 again. And we'll print which is kind of a silly thing to do. But what I'll do is I'll print it all in one line. So what I'll do is I'll use the end operator to finish the line with a space instead of finishing it with a new line. As by default, the print statement prints whatever's inside the parentheses and then generates a new line, right? Well, if you put the end operator in, you can make it end with something else. And in this case, I'm going to make it end with an empty string. So it should print all in one line. However, I've still got an endless loop right now. To make it not an endless loop, I can use a plus equals operator. That's called the augmented assignment operator for addition. That's a big name for two little characters, right? But that's the augmented assignment operator for addition. This is also covered in this chapter. And if I try this now, it won't be an endless loop because eventually num gets up to 10 and that stops the loop. So how many hellos did I get? I got 3, 4, 5, 6, 7, 8. I got nine hellos, I believe. Yeah, 9 hellos altogether because I started at 1. Now, had I started at 0, I would have got 10 hellos. But what's the value of num after this loop is finished? Well, let's see. I should be able to get it by just typing in num, and it's 10. You see, that's what stopped the loop. While num is less than 10, these indented statements will execute. As soon as num gets to be 10, this evaluates as false. That's what stopped the loop. Okay, so the thing about while loops too is they're great for using for when you're not sure how many times a loop has to cycle. That's when you want to use a while loop. Okay, that's the rule for when you use a while loop. Let's try a sample program here. Remember, this is not programming. We're just messing around with some statements here. So I'm going to actually write a program this time. And what we'll do here is we'll, let's see what we'll do. We'll call it while1.py. And I'll try to describe the problem with some triple quotes here. So we'll say, write a program that will use a while loop to prompt the user for integers and what we'll do is we'll say continue with a prompt that clearly explains, or how about we say tells the user what to do. And what we'll do is we'll try to add up these integers. And this program should finish by, let's say, printing the total of all the integers. Okay, so now I'll close my triple quotes back here. It's an interesting way to put comments in a program using triple quotes. Now, I'm going to use main. So I'm going to go with def main like we always do. And we'll prompt the user to, this time, I'm not going to say enter an integer. I'll have something like, let's call it cycle. I'll use cycle equals, we'll say, want more inputs. And we'll leave it with the yn so that the user will know what's expected of them. I'm going to put that inside of an input. Okay, so it's going to start like that. And now we'll use that to start a while loop. While cycle equals y. Okay, so this time the condition that's going to be evaluated to determine if this loop is going to cycle and keep cycling is going to be if the user enters a y. Anything else, actually, it doesn't matter whether this is and. This could be y or anything, because only y is going to keep the loop cycling. So what we'll do inside the loop is we'll ask the user to enter an integer. So I'll call that num. And to enter an integer, that's int input, as I think we've covered many times before. So here we'll just say enter an integer. Okay, but now I want to add these up. So if I want to add these integers up, I have to create what's called an accumulator variable. But whenever you create an accumulator variable, you have to assign it before the loop starts that's going to do the accumulating. So I need something actually right here. And I'm going to call it total. It's a good name for an accumulator. Total equals, and 0 is, it's important that you give it an initial value of 0. So this is our accumulator variable, and we're initializing it. Excuse me. We're initializing it to 0. And that's something you always want to do with an accumulator. You want to give it an initial value of 0. Okay, so and then what we'll do as after each input, we'll add that num onto our total. So that would be done like this: total plus equals the num variable. That'll add the num onto the total. Once again, it's that plus equals operator. That's the augmented assignment operator for addition. Now, if we want this to continue, we've got to ask this question here again. We have to repeat this line. So what I'll do is I'll just actually copy it verbatim here and paste it down below. It should be the final line inside the loop. So I'll paste it down here. But that's not quite right, because that line is not inside the loop. It's got to be inside the loop. It has to be indented. That's inside the loop. Very important, right? Watch your indentation. And by the way, indentation has to be consistent, exactly the same number of spaces. I just inserted a space now. These don't line up now. Okay, the best way to do your indentation is not with the space bar, by the way, it's with the tab key. Tab, 2 tabs in that case. So this is inside the loop. Now this is going to just keep running as long as we enter a Y. And let's, it's not done yet really, but I think we can get it to run. Let's try making it run by putting main right up against the margin here. Once again, we don't want to do that. That would put main inside the loop, but that's not going to work out. So it's got to be right up here at the margin. So let's give it a try. I'll save it as while one as soon as I run it. I'll save it on my desktop. And we're going to call it while one, while_1. Okay, so there's the prompt, want more inputs, yes or no. So if I answer no, the loop skipped entirely, right? The loop doesn't even start. The loop doesn't even start. I'm going to get this off the screen, so I'm going to start with a fresh window here. Now, if I answer no, the loop skips entirely because this evaluates as false, right? It's not equal to y. If I don't enter a y, I entered n. So therefore, the loop condition here evaluates as false. The entire loop is skipped. But if I answer yes, I'll try it again, and we'll answer yes. Now I'm inside the loop, and I'll enter an integer. So I'll try 12. And this line is now working, right? That's this line executing inside the loop. It's already done the totaling. So I'll answer yes to give the loop a chance to cycle again. So I can enter another integer. I'll try 3. And yep, I'll enter another one. I'll try just 2. Yeah, I'll enter another one. I'll try 5. Okay, so let's say I don't want to enter any more integers. I'll enter n. I actually could enter anything but y. It doesn't have to actually be n. And that should stop the loop. Okay, but what's the total? I don't know what the total is, unfortunately. The program worked, sort of, but except it left out this part. We want to print the total. So after the loop, we need a print statement. So unindented, right here, we want a print statement. And I think this is a good case for an F string. So we could say the total is, and then inside your placeholder, put the total variable. It's just an integer, so we don't need to format it in any way. So this will be much improved. I'll try it again with a fresh screen. And we'll just try some, the counting numbers. 1, well, 1 was wrong there, right? I was supposed to enter y or n. And it skipped the entire loop and the total stays at 0, which you would expect that to be true, right? Because we didn't actually run the program properly. So we'll run it again. I'll try 1, yes, 2, yes, 3, yes, 4, yes. And now I'll say 5, and that's the last one. This time I'll try entering the n. Total is 15. I guess that's right. 1 plus 2 plus 3 plus 4 plus 5. Yeah, that is 15 if you add those up. Now, I'm not saying that that's the best program that you could write to add up those integers. I think it would be better with a sentinel value of 0. But I wanted you to see that there's one way that you can make a loop cycle as many times as you want. It's up to you as the programmer. You've got control. The secret is right here. You have to have this something to test. You have to have some variable to test. Well, the variable that we're going to test is the cycle variable. I call this the priming read, or I should say the priming input. This is the priming input that gets ready for the loop. And this input down here, I would call that the continuation input. Because whatever we do here is going to determine if the loop continues to cycle or not. Here, we're setting up a variable that's going to be used to control the loop, the cycle variable. Okay, so you always have to have that priming input, and then you have to repeat it down here. That's how while loops work. Any question about that one? Okay, it's a little bit of a review of while loops. Now, There's another way you can use a while loop that could be kind of similar to this, but I'll use a sentinel value instead. Another way that we could have written this program, what I'll actually do is I'll just modify it slightly up here. I'll call it while2. And what I'll do is I'll just modify it here a little bit by saying using 0 as a sentinel. Okay, so we'll modify that a little bit. Now I'm going to save it right away with that new name. Otherwise, if I run this right now, I'll overwrite the previous program. So file save as, and I'm going to call it while2. And check up in the title bar. Yep, looks like it's been renamed properly up here in the title bar. Now, I want to modify this a little bit. So here we're going to just, instead of having a sort of 2 steps, I think this will be a superior program. This time we'll say num here. We'll use the num variable here, and we'll go with int input, and we'll change the prompt completely. We'll say enter an integer or 0 to quit. We're going to use 0 as a sentinel value. Okay, but that's still the priming input. We have to have some variable to test. We're going to still use this total accumulator, but we're going to change the while condition completely. Now the while condition is going to be while num is not equal to 0. That's using 0 as a sentinel. As soon as we enter 0, that'll stop the loop. As long as while is not a 0, pardon me, as long as num is not a 0, the statements inside the loop will continue to execute. So this time, the priming input is up here. That's what has to be at the last, that's got to be the last statement inside the loop for this to work properly. So I'm going to copy that again. Copy that, and it's got to go down here. So I'll paste it in. Got to make sure it's indented properly though. A couple tabs will do that. This line here, I don't need at all, right? Don't need that line at all, because as soon as we enter a number, it'll get added on to the total, and then we'll have the continuation input here. So it turns out, I think this would be a little bit simpler. As you can see, there's fewer statements actually in this program, and it actually runs a little bit better. If we compare the outputs, I think you'll see what I'm talking about here. So what we'll do with this is we'll give it a run. Right now, I think we've got it right, but we'll find out. Okay, I'm just going to enter 1, 2, 3, 4, 5, and 0 to quit. Well, it added up the numbers the same way. We got 15 as before, but I would say this is a better program because look, I only had to do one thing as the user. All I had to do was enter the integer that I wanted to total up. I didn't have the 2-step process that we had up here. But there's always more than one way to get a job done. Sometimes one way is better than another. I would say that the second approach is the superior one here, using 0 as a sentinel. And why is 0 a good choice? Well, 0 doesn't change the total, right? So that's a good choice when you're adding things up. Use 0, since the 0 will not modify the total. Okay, so I hope you're okay with that. That's how while loops work. But you can do all kinds of other things with while loops too. Like you could do something. Let's make another one really quickly here, and we'll call it while 3. So I'll save it right away with that new name so I don't overwrite the other program. We'll call it while3. And hopefully this is going to go on my desktop. I think so. And what we'll do with this one is, well, I'll dispense with the comment on this one here. What we'll do here is we'll just maybe do something sort of mathematical here. We'll instead of getting input from the user this time, we'll make this not an interactive program. I'll just go with num. I tend to use num as a variable name for an integer. I'm going to start with num equals 0. And what we'll do is we'll, instead of adding things up this time, what we'll do is we'll run while num is less than 11. We'll make this loop cycle while num is less than 11. So what I'm thinking of doing is, what we'll do is we'll just, well, actually, I could kind of make it sort of like the output of this program. If I were to make this a 6 here and start this with a total plus equals num, and here just put num plus equals 1, that would add 1 onto num, right? Plus equals 1 adds 1 onto num. I would call this incrementing. When we're only adding 1, that's incrementing. When we're adding another value that's not 1 onto a variable, I would call that accumulation. So this should continue to cycle while num is less than 6. But right now I've got an endless loop because, well, no, I don't, because adding on to num is eventually going to get up to 6. That should stop the loop. So let's try this one. No, this one's not interactive at all, right? Doesn't ask the user for anything. Here we go. Crashed. I don't have a total variable, but bad coding on my part. But let's see what we can learn from it. The error message is very instructive. I want you to get used to the error messages because they're very helpful. Let's see what the error message is. Variable total reference before assignment. Yeah, right here in this line, I've tried to use the total variable and I've tried to do some math with it, but the program doesn't know anything about the total variable. So I still need to have my accumulator up at the top here. I still need my total equals 0 before the loop starts. You have to initialize that accumulator before the loop starts. So that's the part I left out. So I make mistakes too. Every programmer makes mistakes from time to time. That's part of the job. Let's try it again. I think we've solved the problem here. Done. There's the total 15, same total that we had before. But if all we wanted to do is add up the numbers from 1 to 5, this is a better program, I guess, right? Simpler, much simpler. What made the loop stop? When this got up to 6. If we were, we could actually add another print here just to make a point. We could say num is, and then in a placeholder, put the num variable. And I think we'll get some input that makes sense here. We'll try it one more time here. Yeah, see, that's what stopped the loop. The final value of num in this program is 6. Num is not less than 6. It's equal to 6. So this evaluated as false. That's what stopped the loop, you see. Num got up to be 6. So there's all kinds of other things. Now, I'm not doing very much here. I'm just adding them up, but I could I could be printing something inside the loop. I haven't printed anything inside the loop. I could, right? We could print the values inside the loop, the values of num. We could even make a table of, we could square the num or whatever, right? We could make it a table of squares and cubes, etc. Okay. I mean, the limit is your imagination, what you can do inside of a loop, which is why programmers like working with them. They're lots of fun. Okay, so that's while loops. I hope you're okay with while loops. There is one more usage though. I shouldn't leave while loops before one concept, and that's input validation loops. Back to that document, right down at the bottom here, you'll see input validation loops. Well, you want to make sure that the input is correct in your program. So you can force the user to enter the right input if you use what's called an input validation loop in your programming. I think we should try one of those before we move on to for loops. So let's try one here. So we'll make one here called while for .py, not 34, and I'll save it right away with that name. Feel free to jump in with a question anytime now. If you have a question, or if you can add to what we're doing, by all means do so. Okay, so what we'll try this time, this is going to be an input validation loop. And let me just say what we want. What we want to do here, I'll use triple quotes, and we'll say, write a program that adds integers like before, but they must be even. Use input validation to enforce even. So it's a little bit sketchy, but I think you'll get the idea as we write this. So what we're going to do is we're not going to add them up here. What we'll do is we'll just print them out. We'll just respond to good input or bad input based on what the user enters. Okay. Okay. So no, we do want to add them up. So we do need an accumulator. So we do want total equals 0. And we're going to ask the user to enter an even integer. And how about 0 to quit again? So once again, I'll go with num equals int input. And we'll say enter an even integer. We'll put that in caps just to emphasize it. Okay, so what we'll do is while num. Now, I want it to be an even integer, or I don't want the loop to even start. So how do I test for even on that variable num? What's the rule for even? Dana, you know that one? What's the test? No?
Yeah, it's divide equal. Wait, no, it's divide 2 equal 0.
Yeah, that's right. That's right. And when you say divide, I know you meant the percent
Sorry.
sign, right?
Yes, the
Yeah,
percent sign, yes.
that's right. Right. %2 equals 0. Right. That's the test for even. If the remainder, remember, that's what the percent operator is. The percent operator gives you the remainder after a division. Well, if you divide a number by 2 and the remainder is equal to 0, you got an even number, right? So that's the test. So what we'll do is we'll add that onto the total. So we would say here, total plus equals num. But now we have to repeat this, right? As before, this is the priming read. So I'm going to copy that line and put it inside the loop as the last line in the loop. Paste it in here. But right now it's not inside the loop. So I got to hit one more tab and put it inside the loop like that. Now, if I want to report the total, I probably don't want to print the total every time I've entered a number. I mean, it's possible that you could do that. Generally speaking, though, you want to display the total after the loop finishes. So after the loop, I'll backspace once so that I'm out of the loop now. And I could use an F string to say the total of the evens is, and we would use our total variable inside here, inside the placeholder. So I think that's going to work. Let's see if that one works. This is the priming read. I'll put the comment in here just to make the point. This is the priming read that's going to determine if the loop starts at all. And then down here, when we reuse it down here, this is the continuation read, which is going to determine if the loop's going to carry on or not. So that's our continuation read. So let's give it a try. Okay, here we go. Oh, got something wrong with the indentation up here. That's a strange place to see the error message, but
You have 2 def mains.
oh yeah, yeah, definitely that would be a problem. Thanks. Thanks very much. Here, I'll get rid of this one. Thank you. Okay, thanks for that. Okay, it's running, but I'd like to start with a new window here. So I'll kill that off, and here we go with a brand new window. Let's see how this thing runs. Well, I'll get it wrong. Didn't run at all, right? Because this evaluated as false, right? And the total of the evens is 0 because I didn't enter an even number. I entered an odd number. So I guess it's running properly. I just didn't use it properly as the user. So we'll try it again. Okay, I'll try 4. Okay, I'll try 6. Okay, I'll try 7. That stopped it. As soon as I entered something that wasn't even, that stopped the loop. And I got the total 4 plus 6. That might not be exactly what you want, but I think you get the idea that if you only want to add up even numbers, that's how you could do it. As soon as I entered the odd number, this evaluated as false, the loop stopped, and this line here printed. Okay, so that's pretty much everything with while loops. Although, I mean, I could write while loops all day, different types of them. There's so many things you can do with while loops. Let's take a look at the next type of loop. Just as a quick review, let's take a look at for loops. We go back to this document here, which is the very first item inside module 4, the chapter 4 section. For loops, Python for loops. For loops are count controlled loops. Use them when you know how many times you want the loop to cycle, when it's definite how many times you want that loop to cycle. And in order to get that done, you use a loop control variable to control the number of cycles. Nice thing about using a for loop, endless loops won't happen. Okay, you won't get an endless loop with a for loop. And the range function is particularly useful, as is covered in your textbook on page 170, 178. So let's take a look at an example of using Python for loops. We'll fire up idle again. And what we could do, I'll just actually try it right here in the interactive window. I'll go with for n in range 5 colon. That's how you could start a for loop using the range function. I'm using n as my variable. That's the loop control variable, and it's going to range from 0 to 4. We'll find out. Once again, you finish it with a colon. What am I going to do inside this loop? Well, I'll just do something not particularly amazing, but what we'll do is we'll print out the value of n all on one line. That's what it did, right? Notice it goes from 0 to 4. It doesn't get up to the 5, and it starts at 0 by default. But it does run 5 times. We got five outputs. The loop did run 5 times. So whenever you want a loop to run 5 times, this is a great way to do it. When you know the number of cycles that the loop has to go through, just put that number inside the range function and use a for loop. And I'm using the variable n inside the loop, but you don't have to. I could repeat this, but I'll just modify it. Instead of printing out the value of n, I could do something else, which, you know, kind of silly, but I could print the word hello 5 times, I guess. So you don't have to use that variable n. It controls how many times the loop cycles, and you can use it inside the loop, which is great, but you don't have to. You could do other things 5 times or as many times as you specify by the number here. Now, this is just one of the ways that you can use the range function, though. You can do it you can use it in many, many other ways. For example, I'll go back up to this one and repeat it, but I'm going to modify it slightly before I press enter. I'm going to put a 1 in here and a comma. So now it's going to start at 1 instead of 0. When you put 2 numbers separated by a comma, the first number is the start, and then this is the stop. But as we know, it doesn't actually get to that stop. So let's see what we get for this. It only ran 4 times, not 5 times, but it did start at 1. So if you want, you can do that. I could modify that. Let's say I don't want just 1 and 5. What if I wanted to go from 10 to 50? Should be able to do that too, all in one line. But it didn't get to 50. Once again, stops at 1 less than 50. If I wanted to get to 50, I'd have to make this 51. All in one line. Now it's, you know, kind of pointless to do that, but it is possible to get that all in one line, as you can see. So this loop cycled quite a few times. So start, stop, but this stop is you get to 1 less than whatever that is. But there's one more thing that you can do. You can also add a 3rd number inside, or a 3rd value inside the range, which would be the step. So I'm going to put a 10 in here. So we'll go with by a step of 10. If you don't put this number in, the step is automatically 1. It defaults to be 1. But this time I'd like to get 50. So I'm going to make this something more than 50. 51 should be okay. So let's see what we get when we run this. Right, it goes from 10 up to 50 by tens. See, the step is 10. Each time the loop cycles, 10 gets added on to my n variable. Now, obviously, I'm not doing very much there, just printing out the value of n, but we could do something much more interesting. We could instead print, we could use an f string. We could go f, and we could print n. And we could then also print maybe n squared. And as you know, you do that with a double asterisk, right? And got to make sure I close my string here. Now, the problem with this is not going to look very good because it's going to kind of jam together. But let's see what we got. It actually did work, but the output's pretty terrible. It looks like one big number on each line. So I think we can improve that substantially if we repeat it. But if I press enter on this line, I can repeat that code. What I need now is column widths. So I'll go with n in a column 5 characters wide, and maybe left aligned. That would be left aligned in a column 5 characters wide. This is where you need to use the various ways you can modify your placeholder. This is all back in chapter 2. We really didn't get to using it in chapter 2 because we didn't know about loops in chapter 2. But what I'd like to do here is for the square, I'd like to put it in a column that's how about 6 characters wide, and maybe right aligned. So we'll right align that in a column 6 characters wide. So let's see what happens when we run that. Yeah, much better output. It still goes from 10 to 50 as far as the value of n, but now we're getting the squares of the numbers from 10 to 50 in a separate column. Notice these are left aligned. Notice these are right aligned in a column that's 6 characters wide. Now we can verify that by using our cursor arrow key. I'll try it right here. I'll go right to the far left of this row, and I'm going to count as I press my cursor to the right key. 1, 2, 3, 4, 5. That's actually the end of the first column. Now I'll count, and I should get 6 at the end of my 2500. 1, 2, 3, 4, 5, 6. Beautiful, right on the money. So you get total control of every space in the output if you use the modifying capabilities of the placeholder. So you can see you can do all kinds of fabulous things with for loops. You could, by the way, I could have done this with the while loop too. We could have done this with the while loop, but for loops are great because you don't have that danger of an endless loop. And it's, I don't know, for some reason I gravitate towards using them most of the time personally. They're easier, a little bit easier to work with, I think. So that's how you can work with a for loop. But that's not everything about a for loop. But I think what we better do is write a program. Now, remember, we're just messing around with the interactive window here. So let's try a program that works with the for loop. Let's make one called, for loop _1.py. And what we could do is, once again, I'll use triple quotes here, and we'll say code table of integers from 10 to 100 and their square roots, say. And we'll just leave it at that for the time being. Now, obviously, we're going to have to create some columns here. So we're going to have to use placeholders and alignment features. So let's see if we can do this. And this is definitely a good, you know what I should do though? I should say, I'll say in steps of 10. Make that a little bit more clear. So all I need now is a for loop that's going to go from 10 to 100 in steps of 10. So we could say for n or x. I mean, you don't have to use n. I tend to use n is because it's a short form per number. But of course, if you've taken algebra, you could certainly use x. So we could say for x in range. And I want to go from 10 to 100. So I need to go past 100 to get the 100. So I'll make it 101. And I want the step to be 10. And then my colon. Now, what I want to do is I want to print out the value of x and then also the square root of x. And what I could do is I could calculate the square root first. I could say root equals x double asterisk 0.5. 0.5 would be the same thing as finding the square root. Some of you may have learned that in math class. If you take something to the 1/2 power, that's equivalent to getting the square root. So that should give us the square root of x. So now what I want to do is I want to print that out, and this would be a great place to use an F string. So what we could do is, let's see, why don't we center everything? We'll center both the value of x and also the square roots. Won't look quite so good though, but let's try it. So we'll go with 2 placeholders, one for x and one for the square roots. And now let's put what's got to go inside those. X, and I'd like to center that. And maybe I could center that. It's the caret that you use for centering, right? Shift 6, that should cause centering. And I'll put it in a column that's, how about maybe 7 characters wide. Let's see what happens with that. And now for this one, for the square root, I want to show some decimal places here. And so what I'd like to do is show about quite a few decimal places. Let's say I want to see 5 decimal places. Well, I better make the width much more than that then. So, but I will center it and we'll make it a column that's about 10 characters wide with 5 decimal places. So that would be 5F. So that's what, there's a lot, quite a bit in here, right? Let's look at this. What that means is whenever you want to format the variable, you got to start with the colon. If you want to center it, that's the caret. The 10 means it's going to be in a column 10 characters wide. And the 0.5F means it's going to show 5 decimal places. So let's see what we get for that. And now all we have to put back here is main. And let's see what it does. I'm going to call it for loop 1. So I'll save it like that on my desktop as for loop 1, not for lap, but for loop 1. There it is. There it is right here. I'll try a fresh new window. Okay. So you can see we've got from 10 to 100. This is centered. It's kind of hard to tell because I didn't put any boundaries on the left or right boundary. And this is also centered. And as you can see, we do have 5 decimal places. That because the decimal places don't line up, so it's not so great centering, really. It would be better if it were right aligned, I think. If it's right aligned, I'll just repeat it. Oh, I didn't show you the output there. Sorry, here's the output. And I'll try it again, but I'll use right alignment. So I'm going to change it right there instead of centering. Now the decimal places all line up, so I think that's superior. But look at the control that you have, and look at all the output. This is why I personally love working with loops. I just get a real buzz out of it, because look at all the output. I generated all this output with just a little bit of code. It's amazing, very powerful. Loops are awesome. And I've just got square roots. We could do another column. We could add as many columns as we want. We could get cube roots, etc. We could do whatever we wanted with these values. For loops are awesome. Now let's see. By the way, I didn't put a space here. You might be tempted to put a space there, but if I put a space there, that's going to mess up the column width, isn't it? So I would say don't put any spaces if you're trying to create columns. Now, we could, let's see what happens if I put a pipe symbol right here. That's the symbol above your enter key. You have to shift to get it. Looks like a vertical bar. Let's see what happens if I do that and that. Oops, not that one, but that one. Let's see what that does. Yeah, it kind of shows the columns a bit better, right? Now you can see the column widths, and you can see that this is, in fact, 7 characters. There's 2 before and 2 after the 3. And you can see that this is actually 10 characters. You could count them from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, exactly. Okay, now I don't expect you to put those pipe symbols in, but if you wanted to get the columns, you could. By the way, if you wanted to get really fancy and try to make it look like a table might look, you could even try to print an underline. Wonder how the heck we could do that. How many characters altogether are we printing? We're printing 7 plus 10, 17 plus 3 vertical symbols. So if I were to, after this line, if I were to print 17 hyphens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I mean, this is a pretty crude way of doing it, but let's see what happens if I run that. Not sure if I got that right on the count, but you can kind of make it look like it. Well, I guess I didn't. I don't have nearly enough hyphens, obviously. Looks like I'm short by maybe 3. Try it one more time. Yeah, looks not too bad. You can actually, if you make this into a plus sign, it kind of makes it look like a corner better too. Like there's all kinds of things that you can do, but you know, we're not going to force you to do something like that. Okay, but loops are awesome. For loops particularly. There's something else we need to show you about for loops though. This for loop and all the for loops we've had a look at so far, they've been going up, right? This is going from 10 up to 100. What if we want to go backwards? What if we want to descend instead? Well, let's modify that a little bit. So I'm going to modify the program. We're going to make it for loop 2. I'll save it right away with that new name. File save as for loop 2, just so I don't overwrite the previous program, which I've done many times. So that's why I always try to be careful about it. So now we're going to go from 100. Let's go from 100 down to 0 in steps of minus 10. Well, what we could do, instead of 10, why don't we try 5? And we'll also print out their square roots. So in order to go from 100 down to 0, that means the start is going to be 100. The stop is going to be 0. And the step is going to be not 10, but -5. So we're going to go from 100 down to 0 with a step of -5 in each cycle. Each loop cycle, the value of x will decrease by 5. But this won't actually get down to 0, just like when it was 100, we never got to 100. So what we need to do is we have to go a little bit past 0. So I'm going to make it -1. And then I think I will get down to 0. So I'm going to dispense with this. That was kind of a goofy idea. We won't bother with that. And let's try this again. And this is going to print quite a bit. So I'm just start a fresh new window. Beautiful. Look at that. I got the numbers from 100 down to 0, decreasing by 5 every time. And I got the square roots of them all. Look at all that output from hardly any code. Coders love loops because of the power that they have. Pretty awesome. And of course, if I had a step of -1, I would get every number from 100 down to 0, right? Okay. Hope you're all right with that. Everybody okay with why that runs the way it does? If you have a question, by all means, please ask. Now we could do other things, like maybe I'd like to see the not just the square root, but also the square of these numbers. Well, all I'd have to do is add it into the placeholder right here. I could say, okay, give me x squared. And I'll put that in a column that's maybe right aligned, might be better. That's 10 characters wide. I think that would do it, as long as I finish my placeholder here. So now I'll get squares as well. Let's see what happens. Give that a run. Not much of a modification. Now I've got the squares of those numbers, all the way from 100 down to 0. 70 squared is 4,900. They're right aligned, as you can see. Now, whenever you're making a table, it always helps to put column headings on. So let's see if we can do that. Let's see if we can put column headings above each of these columns here. Well, in order to do that, we should be mindful of the width of the columns. And we need to put the column headings before the loop starts, right? You wouldn't want to put them inside the loop, otherwise the headings will print out in every loop cycle. So we'll put the headings up here. And what we could do is we could actually copy this, because this has got the formatting that we need. So I'm going to copy that line completely and paste it in before my loop starts here. Just making sure that it's indented properly though, which would be right there. Now I want something inside of a column that's 7 characters wide, but it can't be X. This has to be my column heading. So I'll just call it, I'll call it X, and I'll capitalize it too, just for the heck of it. And then here, I'll use a column that's 10 characters wide, and I don't want root. What I want is a string. Now you notice I'm using double quotes, by the way. I have to use double quotes because my F string starts with single quotes. If I were to use single quotes, that would finish the string. So I got to use double quotes inside the single quotes here. So this is going to be, I'll just call it root. We'll capitalize it. But the 0.5f would have no meaning for a string. We can't, no decimal places in a string. So all we want is just the 10. We want the width, but not the formatting of the string. And over here, we want, I guess what we want is square. But I'll capitalize it as well. And 10 should be okay for that. So so let's see what that does. I think I might have it, but you know, I don't get my programs right every time, as we saw earlier today. Let's give it a try. That's not too bad. I think I could maybe dispense with these. Maybe take these away. But if I do that, I should allow for where they might appear though. So I will put a space in. Like we could mess around with this all day. What I could do is underline those, I suppose, right? I could try to underline those if I wanted to as column headings. I don't think it's really necessary, but maybe a blank print after to sort of set them apart from the rest of the table would be a nice touch. Something like that might be better. Maybe it isn't better. I don't know. Always little things that you can do. But the main point is loops can descend as well. Now, you have to write a program for your assignment where you have to draw a triangle with asterisks. And that's got to be a descending loop because you have to print out a series of lines. Let's see if, I think I've still got our page loaded here. Yeah, if I go back to module 4 in my courses, and if I take a look at the assignment for this chapter, so I really shouldn't be jumping to this, but see if we take a look at the assignment. One of the things you have to do is you have to generate this output here, making a triangle with asterisks. Well, you'll notice that it starts off with a number, looks like about 10 or 12 of them, and it's one less in every line. So you have to, this is a descending type of loop that you need, but you need nested loops. You need one loop inside another loop in order to make this work. But your outer loop is going to be a descending loop, definitely. Okay, so that's a big hint on that one. When you're trying to figure out a program like this, I would suggest you grab a pencil and paper, by the way. Just grab a pencil and paper and sort of analyze what's going on. First row, 10 asterisks, next row, 9 asterisks, and so on. So then you can see, it's the value of the loop control variable must be descending. And that's the clue to how to solve the program. Here's a table, kind of like what we did a moment ago. You can see we do have column headings here. So we kind of covered that. And This one here is using a while loop to enter positive integers using a sentinel value. Well, we kind of covered that today too. So I'm hoping that you're going to be able to do this. Well, I've got 1047. That's quite a haul. We've been here for quite a while. Let's take 5. Come on back here at 1052, and I'm going to run a Kahoot with you to see how much you remember about how loops work. We'll try a program that uses a Kahoot. We'll quiz you all with the Kahoot, have a little bit of fun, and test our knowledge of loops. So come on back at 10, let's make it 1053. I've got 1048 now. So take a 5-minute break. I'll stop recording now. Please remind me to start recording when we come back, in case I forget. Okay, we're back. And we're going to try Kahoot. Here we go. You can log in with your computer. You can log in with your phone. You can log in with a tablet. Just go to kahoot.it, enter that number. That's the number of our game that we're going to play. Enter your name. I suppose if you're the shy type, you could use a pseudonym. But then what if you win? You won't get all the adulation and glory if you don't use your own name. By the way, I'm enjoying a cup of coffee from Real Python. I've got a mug from realpython.com. Outstanding website, by the way. All kinds of great tutorials and courses that you can take there for free. All you got to do is sign up and bear with the daily emails. Okay, we got 7 players. Come on now. We should have 14 players according to the participants in this Zoom. All you got to do is go to kahoot.it. You could open a new window on your browser, whatever browser you're using. Go to kahoot.it, enter that number, enter your name, and we'll get started in just a moment. We've got 9 questions in this Kahoot, and they're all time limited, and you get more points if you answer quickly. Of course, you have to answer correctly. Come on now, we got some people haven't joined us here. I don't see Solomon. Come on, Solomon. I don't see Shannon, I don't think. I don't see Dana's here. Kayla, Ben is here. Abby, come on, Abby. Let's play. You can actually have fun with Python. Imagine that. What a concept. Okay, we've got 10 now. Oh, there we go. We got 10 players. All right, I'm going to start. Last call for players. Okay, thank you for joining, folks. I appreciate that. That's pretty good. All right, here we go. What type of loop is a pretest loop? That's right. While loops are pretest loops. Yeah. The test is at the start of the code, isn't it? If the test is false from the get-go, the loop is skipped entirely. That's why we call a while loop a pretest loop. I might not have made that point real well today when we were discussing loops, but it is in the textbook, I believe. All right, let's see what happened there. Kasaya and Kayla very close behind. Very good. Remember, you get more points if you answer quickly. Here we go. Question 2. Five, four, three. Yeah. While x is greater than 2. And that as soon as you get to 2, it's not greater than 2. So you get 5, 4, 3. I suppose, unfortunately, I can't really copy that. Can't drag across that to copy paste it into Python. But okay, let's see how that worked out. Josiah got that one right again. Jack close behind, and Kayla is also very close. It's a little trickier, so I've given you quite a bit of time on this one. Don't answer too quickly. We're accumulating here, as you can see. We've got our total variable as an accumulator. Pretty tricky. If you go through it, keep track of the total, you can get it. Yes, 1 plus 2 plus 3 plus 4 equals 10. See how we made out there. Jack takes over the lead. All right. Question 4. Another accumulation program, but this time it's a for loop. Yeah, remember range 5 means n goes 0, 1, 2, 3, 4. If you add those up, 1, 2, 3, and 4 adds up to 10. Here's a for loop with a range function with 3 numbers. Yeah, very good. Most of you got that one. It's a step of 2 and never does get to the 8, remember? Remember how that works? Pardon me, it never does get to the 10. So really it goes 2, 4, 6, 8. We don't get to the 10 because remember, 1 less than this number. Jack's still in the lead, but we've got quite a few people close behind. Yeah, accumulator, exactly. Counters go up by 1. They don't total. Counters increment. They go up by 1. Kasaya retakes the lead. Got quite a battle going here. 4 people very close. While loop. While loop is what you want for input validation. Yeah, while loop, definitely. Dana moved up. 2 more questions. Now we have a descending loop. Yeah, 14. The reason for that, it's a descending loop and it's going to go from 5 down to 1. Well, remember, it won't get to 1. It gets to 1 away from it. So it's actually going to stop at 2, decreasing by 1 each time. So we have to add up 5 plus 4 plus 3 plus 2. That adds up to 14. Kayla takes over the lead. All right, we've got quite a few people in range though. Last question. Nested loops. Yeah, very good. Nested loops. All right, let's see how we made out here. The podium. The bronze goes to Kasaya. The silver goes to Dana. And the gold goes to Kayla. All right. Well, I hope you found that instructive. And we'll do those for each topic that we have. Now, I wanted to carry on today with, I do want to introduce chapter 5 briefly, but I also want to discuss number systems because it's a very important part of computing and it's something that's covered in module 8. Module 8 is not about Python, actually. Module 8 is about number systems. And we're a couple of weeks away from that, of course, but it's a little bit tricky. So I'd like to cover it a couple of times before we get to it. Basically, we use, what's the number system that we use? What's the base of our number system? Anybody? Anybody know what the base is that we use?
It's base 10, isn't it?
That's right, Dale. That's right, base 10. I wonder how we got to use base 10. Wonder where that came about. Well, here's the answer. We've got 10 digits on our fingers, on our hands. We have 10 digits. That's why we use base 10. And what do we call these? Digits. We call them digits. It's just another word for number, isn't it? So, hey, what about in cartoon land? What would be the probable base in cartoon land? Does anybody know how they draw hands in cartoons? If you ever look at you know, the Simpsons or something like that. And if you look at
They
their
have like
hands,
4
yeah,
fingers.
that's right. For some reason, it looks weird if you draw 5 digits on a hand in a cartoon. You'll always see just 4. So the base would be 8 in cartoon land. Okay, but we use base 10 because of the digits on our hands. Now, what I wanted to do is I'm going to jump to module 8 just real quickly to show you 1 or 2 documents in there. And here's module 8, and you can see that I don't have there's no snake icon on this one, so there's no Python in here, but it's about number systems. So I'm going to load up this PDF document, and yeah, I'm not that crazy, but that one actually, I think I'll go back and try a different one. I think this is better maybe to introduce it. Yeah. Okay, let's just take a look at this for a minute. We use the base 10, also called the decimal system, because we have 10 digits on our hands. But in programming, it's also important to know about base 2 binary numbers. They use base 2, and also base 16 numbers. That's called hexadecimal. Hex, as you know, means 6, right? A hexagon is a 6-sided figure. Well, hexadecimal, that's 6 plus 10, that's base 16. And both of these bases are important in computing. Just to kind of point that out to you, I could open up a command window. Let's see one place where we could show you. If I open up a command window by typing in CMD, if you've got a Mac, you'd be opening up a terminal window, I guess. Does anybody know how I could get my IP address? If you've done any networking at all, I can enter a command right now and get my IP address.
IP config?
Very good, very good. IP config, excellent. So if I type IP config, I'll get some information about my network. And let's see, my network is, I'm working wirelessly at the moment. And here's my IPv4 address. Look at these numbers here. Okay, those numbers, if on your network is also going to start with 192.168. All small networks do. And presumably you have a small network at home. Okay, and now take a look at this. Here you see the IP version 6 address, which has got letters in it. What's that all about? F, C, E, A, D, different letters. They're all lowercase there. Well, if we were to take a look at hexadecimal, hexadecimal uses base 16, not base 10. But to really understand either binary or hexadecimal, we have to really think about base 10 for a minute. Let's make sure that we understand how base 10 works. How would you explain the number 6347 to somebody from another planet, for example? How would you explain that to them? Well, first of all, you'd have to show them what 10 meant by making a pile of 10 pebbles or something. And then you could say 6347 is 6 times 1,000 plus 3 times 100 plus 4 times 10 plus 7 times 1, because that's what it is, right? We know that this is the thousands digit, this is the 3 is the hundreds digit, and so on. But a better way to do that is to think of these numbers as powers of 10. So instead of 6 times 1,000, think of it as 6 times 10 to the third plus 3 times 10 squared plus 4 times 10 to the first plus 7 times 10 to the 0. Now you might recall from mathematics that anything to the power 0 is 1. So that actually is 7 times 1. So that's how you could understand the number 6347. It's descending powers of the base 10. Notice how they descend from 3 to 1 and 0. Well, that same pattern applies no matter what the base is. So if we wanted to look at base 2, here's a base 2 number. Now, what's interesting about base 2 numbers is they only use the digits 0 and 1. Only 0 and 1. Nothing else. So how would we explain this? Well, if the base is 2, we've got 5 altogether here, right? Five digits altogether. So it's 1 times 2 to the 4th plus 1 times 2 to the 3rd, 0 times 2 squared, and 1 times 2 to the 1st, and 1 times 2 to the 0. Now, if you add up those powers, that's 16, 8, 0, 2, and 1. So that's 27 in our base 10 that we're more familiar with. So this number here is actually 27. Now you might wonder, well, why do we need to know this? If you want to understand networking, you need to know this. Okay, if you want to understand how your router works at its lowest level, how it really operates, you need to binary numbers. Let's take a look at this one. Here's a full 8-bit byte. That's you know the term byte, and a byte consists of 8 bits. Bits are zeros or ones. Binary numbers are made up of binary digits. So if you take those two words, binary digits, and kind of sandwich them together, that's where they came up with the word bit. So an 8-bit byte, here's an example of an 8-bit byte. Well, since there's 8 of them, then the powers go from 7 down to 0. So here's how you can figure out what this worked out to. So this number here turns out to be 189 if you add up the powers of 2. Okay. Now, base 16 works the same way, but base 16 presents another little problem. Think about base 10 for just a second. There's no single character for 10, is there? In base 10, it takes 2, a 1 and a 0. So in base 10, you only get to work with the digits from 0 to 9. Right? That's all we get to work with. 1 less than 10 from 0 to 9. Well, in the base 2 system, we only work with zeros and ones, 1 less than 2, right? There's no other number. There's no 2, 3, or 4 in digits in binary. It's just zeros and ones, because a bit can either be on or off. On means 1 and off is 0. Well, base 16 works the same way. We have to have a single character to represent the numbers from 0 to 15, 1 less than 16. So what are we going to do when we get to 10? Well, somebody really sharp said, hey, why don't we do it like let them be letters of the alphabet? So because we have to have a single character to represent 10, 11, 12, 13, 14, and 15. So somebody very sharp said, hey, let's use A, B, C, D, E, and F. A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. So in hexadecimal, you've got the digits from 0 to 9, and then A to F, because you have to have a single character for the numbers from 0 to 15. In base 16. By the way, if you had base 8, you'd be working with 0 to 7. Base 5, you'd work with 0 to 4. So what does this number here mean in base 10? B7D. Obviously, that's a hexadecimal number because you see the letters there. Well, first you have to realize, well, B means 11 and D means 13. So therefore, once again, it's descending powers, but now the base is 16. This is the hexadecimal system. So the base is 16. 16 squared, 16 to the first, 16 to the 0. But B is 11, so it's 11 times 16 squared. Well, that's 11 times 256, which is a pretty big number. And 7 times 16 is 112. 13 times 1 is still 13. Well, all that adds up to 2941 here. And that's what this is in hexadecimal. Now, one of the reasons that we like hex, by the way, in IT is you can use fewer digits to express big numbers. notice in base 10 takes 4 characters to express that number, but in hex, it only takes 3. Only takes 3, B7D. Now, we're only going to be using 2-digit hex numbers. We won't get into 3 digits. So most likely, we're just going to do something like FF, for example. What's FF? By the way, that's the biggest number you can get with 2 hex digits. FF. Well, F means 15. So FF means 15 times 16 to the first plus 15 times 16 to the 0. 15 times 16 to the first is 240. 15 times 1 is 15. So you add those up, you get 255. 255 is the highest number that you can get with 2 hex digits. And by the way, as an 8-bit byte, that's all 8 bits on in binary. That's the highest number you can get with 1 byte, 255. Now, I've still got that window open here. Just want you to notice, like, look at my subnet mask, 255, 255, 2550. That's 1 byte, that 255. And here's another byte, here's another byte. So if I were to express this address in hex, it would be FF, FF, FF 0. Okay, now there's one other reason that this is important, and that's for the ASCII coding scheme, the American Standard Code for Information Interchange. We'll load up real quickly here. Let's just try to load up an ASCII table. If I search for ASCII, there it is, ASCII table. And some of them are better than others. Let's see if I can find a good one here. I'll try this one. Yeah, not too fussy on that one. This one's pretty good. Okay, now let's see. Let's start looking at 64. Pardon me, 65 right here. See this first line here, that's 65. That's base 10. Well, in hexadecimal, that's 41. The second column is hex. As you can see the column symbols here, hex. 4 times 16 plus 1, it makes 65. So 41 hex is the same as 65 in base 10. Well, that's capital A in the ASCII coding system. So early on in the development of computers, they said, hey, computers only work with zeros and ones. We humans, we worked with characters that we put together to make words and sentences. That's how we relate to each other. For the computer, everything's just zeros and ones. That's why we call them digital computers. Well, there has to be some way for us to relate to each other. So they developed this coding scheme called ASCII, the American Standard Code for Information Interchange is what that stands for. And this is how they set it up. Capital A is the value 65. Capital B is 66. And you'll notice they're all in order. See the letters of the alphabet here in capitals. And it goes all the way down to 90 for Z here. 90 is Z. Well, you've done sorting probably in Excel, and you've sorted some names or characters. You might have thought you were sorting them with letters of the alphabet. No, you were sorting them based on their numerical value. That's how they were being actually sorted, by their ASCII values. So every character on your keyboard has a particular ASCII value. And every value that's stored in a byte of computer memory has an ASCII value as well, so that we can relate to it. We humans need to work with letters of the alphabet. By the way, the lowercase alphabet kicks in at 97. Here's where capital A here is ASCII 97. And that carries on all the way up to 122 for lowercase z. Now, this is just standard ASCII, which stops at 127. But you'll notice we also have the hex for each ASCII value, as well as the character that it represents. So ASCII is the Rosetta Stone between us and the computer. The computer knows only zeros and ones, bits. We humans, we want characters, letters of the alphabet. And there has to be some relation between them. Well, ASCII is our Rosetta Stone. Now, using that term Rosetta Stone, you may have heard that term before. Does anybody know what the Rosetta Stone is? Now, I'm not referring to the software that allows you to learn another language, which, by the way, was a brilliant name choice for them when they started creating that software. You can get Rosetta Stone to learn Spanish, Rosetta Stone to learn Italian. It's a very well-named piece of software. But the Rosetta Stone itself, does anybody know what that is? Well, if you Google it, you can find out. I'll try it. There it is, Rosetta Stone. It's an actual stone. If I go for the images, there it is. It's an actual stone. Here it is in a museum in London, I believe, or nearby London. It's a pretty good sized stone. And it was found in the desert in North Africa by Napoleon's army when they were messing around in Africa. And it turns out that there's 3 panels on it, 3 different languages. So you get the same message in 3 different languages here. And one of the languages is Egyptian hieroglyphics, the symbols that were found in Egyptian tombs, right? And prior to this stone being found, people had no way of understanding what those hieroglyphics meant. But this has got the same message in some known languages as well as the Egyptian hieroglyphics. So this was the secret to unraveling how Egyptian hieroglyphics could be understood. And here's a close-up of it here, I guess. Let's see. Yeah, I guess this is the hieroglyphics, and this is some other known language down here. So the Rosetta Stone between us and the computer is the ASCII coding scheme. But ASCII actually is pretty incomplete as far as a coding scheme for characters that we humans need to know about. You might have heard of Unicode. Unicode. Well, let's see if I can go to unicode.org here. If you go to unicode.org, Unicode is a coding scheme for all kinds of things, including emojis, but other characters as well. Let's see if I can find the code charts here. This has changed a little bit since the last time I was there. What I want is just the code charts. Maybe I'll change my search. Yeah, I want the code charts. Okay, here we go. Here's the code charts. These are the languages on planet Earth. Look at all these languages. Who knew there were that many different languages on this planet? Look at them all. It's unbelievable. Here's the Middle Eastern languages. Here's South Asian languages. Look at all these languages. No wonder we have trouble getting along. There's too many languages on this planet, right? Well, let's see. Does anybody happen to know Kharosthi? Let's see what's in there. These are the characters in the Kharosthi language in the Unicode system. Unicode is a much bigger coding system than ASCII. It allows for many more characters. It's actually a 16-bit, not an 8-bit system. And so that allows you for 65,000 different characters, not just 255 as ASCII does. So every one of these characters has a particular value in Unicode. But what's kind of cool, actually, if you notice back there earlier, we do have, get back to that. Oh, I guess I can't. I'll have to go back to unicode.org. And you've got your emojis too, right? So all of these emojis, they have a value in Unicode. Let's say this one here, if I take a look at that one, it's 1F601. It's a little bit hard to see when it's small like that. Here's the sad crying emoji. 1F625 apparently is the value for that. Okay, so all of these symbols. So basically what I'm trying to get at here, that code charts, ASCII is a little bit incomplete because it's a small system. Unicode covers more languages, but what we're referring to, the whole reason I started this was to basically explain what ASCII is. And it's a coding system that allows us to interface with the computer. That's the whole idea. But Unicode is a better one by far. Now you can actually do some things in Python. If I were to just fire up a brand new Python window here. In the interactive mode, there's two functions that I could use that we don't have to know these, but if we tried CHR 65, we'll get the character that's the code that's ASCII for 65. Notice it is a capital A. Well, that's the same thing that you could look up on the code chart. By the way, at the back of our textbook, we do have an ASCII chart, right? At the very back of the textbook, you'll see an appendix which has the ASCII tables there. I could change this to 66, and that'll give me a capital B. And they're all in order, CHR. If I want to go the opposite way, if I want to enter a character, so if I tried like ORD, and maybe inside the parentheses, if I put maybe a Z, that's number 122. So it's the opposite of the CHR. CHR, if I tried ORD, capital A, that'll give me the 65, you see. So if you want to get the number associated with the character, use the ORD function. If you want to get the character associated with a numeric value, use the CHR function. Now, we don't want you to know those. You're not going to be tested on those in any one of your assignments, but we'd like to give you a well-rounded education here at SPC. So I thought you might be interested in that. And it is important that you know ASCII, because you can do certain things with the computer with ASCII. And it's definitely important that you understand the binary and hex system. So I guess that's all I want to do for an introduction today. Maybe one more place where it's important to understand hexadecimal. Some of you folks have done HTML, I think, right? I'm sure some of you folks have done some HTML. Well, you might have done some color coding, right? If you want to color something, I'm going to look up HTML color codes, and let's see what I get here. Okay, here's a code chart, and every color is represented by 3 hex numbers, because every color, as you probably know, is a mixture of red, green, and blue, right? So we've got RGB. So this particular color is FF red, 57 in green, and 33 in blue. And it gives you apparently this color here if you mix those. So if I wanted to get strictly red, see if I can get down the bottom here. Notice red is almost, no, it's not totally red, I guess. Hard to find it, but totally red would just be FF0000. No green and no blue. But each one of these could also be indicated with 3 numbers from 0 to 255. 255, the biggest number you can get with an 8-bit byte. So there's several ways that you can express code colors in HTML. And let's see, I can see if I can find another chart here. Okay, we'll enter FF0000. Let's see what we get. Got nothing. Might want the pound sign. Oh, I'm not sure if this is what I just got or not, but there you can see FF0000 gives us a red. If you only turn on the middle 2, that gives you green. If you turn on the last 2, that gives you all blue. But you can have any value from 0 to FF for either the red, the green, or the blue to get all the other possible colors that you can display. So in other words, the point I'm trying to make here is it's important to know hexadecimal if you want to do HTML and get your colors coded properly. You'll run into it there as well. So they pop up all over the place. And there's one more little thing that I wanted to show you really quickly. If I fire up, say, for example, if I just go to a blank spot on my screen, I can make a new text document, and I won't even bother changing its name. So here I've got a text document. This could be a Word document. There's a little keyboarding trick that you can use. You could try it. I don't know if I can do it on this computer here. I've got a new laptop. I'm not even entirely sure how it works. But if you try holding down your Alt key, hold down your Alt key and type 6.5 and then release your Alt key inside of a text file. You should get a capital A if you do that. Yeah, it works on my laptop. I just did Alt 6.5. I'll try Alt 6.6 and then release the Alt key, Alt 6.7. So that's another way of determining what character is associated with a particular ASCII value. If I were to try Alt 122, I guess I should get a, I'm using the numeric keypad, by the way, not the numbers on the top of the screen, top of my keyboard. I'm using my numeric keypad. So Alt 122, release, there's the lowercase c. So that's another way you can find the value associated with it, the character associated with a particular value. Okay, so back to Python. I want to introduce Module 5. Module 5, Chapter 5 is, I'm going to be straight with you, probably the hardest chapter we're going to cover in the course because we have to learn how to write our own functions. But you can do it. We're going to write our own functions. So far, we've used a number of functions that come with Python, right? We've been using quite a few. I'll just minimize this, get rid of that window. If I fire up idle, we've been using a number of our own functions. We've used the print function. We've used the input function, right? We've used those. I guess that's mostly what we've used, right? Is input and print, pretty much. Well, we can also make our own functions. So I'm going to go to the textbook for a moment if it's not gone. Hope I still have it. It's timed out on me, unfortunately. Yeah, darn it. It's all timed out. So instead, I'll go back into my courses and our course page. I get timed out for inactivity. I hate that. So here we are on our course page. And if I go to the course content and open up module 5 and learn here, which is where you should start. Don't start trying to do the program, right? You want to go through all the learning materials here. So I'm going to load up chapter 5 here, key points, where we try to summarize the most important parts in the chapter for you. Functions. Yeah, we've used print and input. Those are all built in. Guido and his friends made those functions for us when Python was first invented. But what we're going to learn about in this chapter, chapter 5, is how to write our own custom functions. That's when you truly become a Python programmer, when you write your own functions, because that's what you'll have to do as a professional. For your clients, for your supervisors, they're going to be asking you to write custom functions all the time. And a custom function is just a name block of code that does a specific task, a specific job of some kind. They are a great tool because they allow you to write code once that will run whenever you need to use it. Just like we can use print wherever we want, right? Whenever we want to print something, we can use that print statement. Well, if you write your own custom function and get it debugged and working properly, then you can reuse it anytime you want in a program in the future. And that's what Python programmers do. If you generate your own function, you'll want to save it so you can use it in the future. Functions can take in the information they need and sometimes return information back. Sometimes what they do is return something. Functions make your programs easier to write, read, test, and fix. Okay, they make your programs easier. Instead of having one big main function, like we've been using so far, just the main function, complex programs typically have a main function which executes the other custom functions. That's usually how you make a major application. And professionals do this all the time. They'll save them so they can use them in the future. And any serious application that people would be interested in today, teams of people write the software, right? If you look at the video games that you folks play, dozens of people work on those games. No one person writes those games. They're too complex. And the way it works is they divide the task up and they say, okay, Henry, you're going to program these functions. Mary, you're going to program these functions. Okay, and then they put them all together for the application. Well, to define a function, you have to first define it before you can use it. And you define it, you start that with a single line of code, just like we do with main. So I think what we'll do, we'll come back to this, but here's a really simple one here. We could have a function called say hello, and I think we'll give it a try. I'll try it right in the interactive window. So we'll try it right here. So I'm going to define a function called say hello. I'll put an underscore in it, which is common, and a colon at the end, just like we do with def main, right? Now, whatever I put in underneath this indented will be inside this function. and it'll execute when I run it. So I'm just going to put here, print hello. And press enter, and nothing happens because all I've done here is define the function. Okay, I've defined it. The def keyword, that def means define. This is the name of the function. You'll always have a set of parentheses when you define a function, and you have to finish it with a colon here, just like we have to with our loops and our if statements. Anything that's indented will execute when we run this function. Well, how do we run this function? The same way we run the main function. What do we do with the main function? We just type in main and the parentheses, right? Well, to run this one, I'll just type in say hello and the parentheses. There it is. It does whatever's inside. Whatever's inside executes. Now I only had one line inside there. I could repeat this and I'll put 2 lines inside. Just do how are you, which is kind of silly, of course, but now I've redefined the function. Now, if I run it again, which I could do by entering this again, now I get 2 lines of output. So I could have thousands of lines in here indented underneath say hello, and they're all going to execute when I enter this. So this is one type of function. Now we're going to look at different types of functions, but get the idea here of what a function is. It's just a block of code with a name. In this case, the name is say hello. You do need the parentheses, and you have to put the colon here to, in the first line. This is called the header line of the function. And then you indent underneath that what you want to have happen when this function is executed, when you run it. Now, this particular function is really simple. It's not taking it's not taking any arguments when we use it. There's nothing inside the parentheses, but I'm going to redefine it. I'm going to enter this again. I'm going to modify it slightly. What I'm going to do is I'm going to put a variable here inside the parenthesis this time. So I'm going to put name right there. And so I'm changing the definition. Once again, nothing happens when you define it. Okay. When you define a function, that's all you're doing. You're not executing the function. You're just saying what the function is going to do when you do execute it. So now I'll try to execute it by entering the say hello again. But this time it's going to crash unless I put something in here. And what I'll put in here is we'll pay our respects to Guido. We're not worthy. But let's see what happens. Didn't work. I didn't get anything back. I mean, it didn't run any differently. So what I would have to do right here is I'd have to modify this print statement to use this variable name, right? What I'm doing here, I'm defining it with a parameter name. And then I'm using Guido as what we call an argument. But if I don't use that variable name inside the function definition, it's pretty pointless. So I'm going to repeat this again by pressing enter on this line up here. I'm going to modify the code slightly. I'm going to turn this into an F string. I'm going to go with F, hello, and then I'll put inside the placeholder here, I'll put the name variable. Now we'll get a very different result when we run it. Once again, we're just defining it now, but now I'll run it again like this. And it says, hello, Guido. So now we have a much more useful function. We're giving it a name to work with. When we define the function, as we did here, we call name the parameter. When we go to use the function, which we're doing here, whatever we put inside the parentheses is called the argument. And the argument gets passed to the parameter. That's the key point. The argument gets passed into the parameter. So the thing about this is we can use this for any name, right? We could say hello, Ichabod. I'm so happy my parents didn't call me Ichabod. But if that was the name, that's what you get. So whatever argument you specify, that's what gets stored in the name variable when you use it internally. Now, sometimes functions will require more than one parameter when you define them. Here we're just defining it with one parameter. Let's try something with some numbers instead of this function. You know what? I'm going to keep this window though. I think what I'll do with this, I want to send this to you later, so I'm going to snip it. I'm going to right click down here and type in snip, get the snipping tool, and I'm going to make a new snip of this. No, I didn't really do that quite right. I'll do that again. I want to get all of, well, that's weird. Never seen that before. It's not working quite the way I wanted it to. So I guess I'll go way up here. Okay. Just want to snip all that out. I'm going to save that. File save as. I'm just going to call it func1 PNG. I'll put that on my desktop so I can send it to you later. Okay. And I'll keep that snip open in case I want to snip something else, which I do. I'm going to go to another window here. So we'll open another blank window. Let's open another interactive window, and we'll define a slightly different function. This time, let's say we want to find area. Now, if you had an area function, well, we could be finding the area of a lot of different things. Let's say it's the area of a rectangle that we want. So I'll call it area rect. And in order to get the area of a rectangle, two things are required, aren't they? The length and the width. So I'm going to go with, I could use len. I don't want to though, because as you can see, it's part of the language because it shows up in purple. So I'll actually go with length and width, because in order to calculate, if we want a function that's going to calculate the area of a rectangle, we need to know what the length and the width are. So what we could do now is we could say area equals, of course, length times width inside this function. And now we could print that out. We could say an F string would be very nice here again. We could say the area is placeholder. And now we could put our area in here. Now maybe we could work with not necessarily integers here. So maybe I'll format this with decimal places, but I definitely need to put the area variable here. And maybe I'd like to format it with 3 decimal places. So I'll go with 0.3f. And if it might be over 1,000, I'll put a comma in here too, just in case it's going to be a big number. So I'll show it with thousands. Okay, so let's say that's it then. That's the definition of a rectangle area function. The name of the function is area rect. It's going to require, if I go to use this now, I have to give it 2 numbers to work with, or it's not going to work properly. I've defined it with 2 parameters. So when I use it, I have to specify 2 parameters. So let's see, I should be able to enter area. And I should be able to do it with just some numbers. So I'll just go with 12 and 5. Let's see what happens there. I don't have a function called area. My bad. The name of my function is rect area. Pardon me, area rect. So I have to make sure I use the right name. Area rect. Now I think it should be okay. And it gives us the right answer, of course. 5 times 12 is 60, and there's our 3 decimal places. So now we have a function that's going to determine the area of a rectangle. It's not a, nothing particularly fantastic, but it does do the job. We could do more. We could modify it. I could just actually change this a little bit. I'm going to call it just rectangle. I'll get rid of the area thing. And I could do more than find the area. I could also find the perimeter, couldn't I? Perimeter is, as you know, 2 times length times width. But in order to, I might be tempted to do it like that, but that would actually be a problem because that would be okay in math class, but not on a computer. I've got to put the asterisk in here to indicate the multiplication. 2 times the length plus the width. I could also say 2 times length plus 2 times width. That would work too. So there's the area. So now I suppose I could add another print line, another F string, and I could say F, the perimeter is, and inside my placeholder, I'll use the perimeter variable. And maybe I would like to format it with maybe just 2 decimal places. So let's see what happens there. Now I've got a totally different function name now. This time it's just called rect, not because I'm doing more than the area, as you can see. So let's see. Nothing happens there, but if I try to run it, I'll just enter rect and 2 values, and I should be able to enter numbers with decimal places too. So I'll try 12.5 and 4.5, for example. I guess that's right. I guess that's what you get. So pretty cool. Functions, I mean, it's just up to you. Now, obviously, this is not anything really fabulous. We could have a task where we might need hundreds or maybe even thousands of statements inside here to do something pretty complicated. But the idea is you define the function. The function might need parameters when you define it. Not all of them. Not all functions require parameters. We could even have inputs inside here, right? We could use an input statement inside here if we wanted to. But in this case, we were defining it with parameters. If you define it with parameters, when you run it, you have to give it 2 values to work with. And the order is important, by the way. This first argument is going to go into this first parameter. This second argument is going to go into this second parameter. And I shouldn't have capitalized that H there, but I hope you get the idea. Now, we call this a void function. This function is not returning a value, right? It's simply doing some stuff. It's doing some math and printing out some results. Another way that we could define the area rect function up here, we could define it a little bit differently, and I will. I'm going to work out the area again, but I'm going to, instead of printing it out, I'm just going to say return area. This is now what we call a value returning function because it returns a value. And these are actually the most useful types of functions. Some functions, you don't need to return a value, but other functions do require you to return a value. For example, if I were to ask you, what's the square root of 9? well, you could print it out, I suppose. But if you were to return it, you would tell me 3, and you would return 3 to me. Okay, so imagine you're a function, you're a square root function. So I'm going to say to you, 16. If you're a value returning function, your response would be 4, obviously, right? Because 4 is the square root of 16. And you would return it to me, and then I could do something with it. So I'm gonna modify the name of this a little bit. I'm gonna call this one return area rect. It's getting a little bit lengthy. I don't like really long names for my functions as a rule, because then I have to write long names when I use them. But here we got return area rect. And let's give it a try. Okay, so this time there's a definition. Remember, defining a function doesn't do anything. It doesn't run it. Now, if I want to run it, how would I run it? I would use the name. So I would type in return area rect. And I do have to give it 2 values to work with. I'll go with 20 and 15. And let's see what I get. I got a 300, which is correct, right? But this isn't really useful unless what if I want to use that free 300 and do something with it? What if I'm carpeting a room that's 20 feet by 15 feet, and I've determined that the area is 300 square feet, but now if I want to buy carpet, what if I want to use that 300? I can't use it. A value returning function like this one is only useful if you catch the value that it returns in a variable. So I'm going to modify how I run this slightly. I'm going to repeat this line, and in front of it, I'm going to put area. I'm going to catch the value it returns in this variable. Now, when I run it, I'm not going to get any output at all, but something was stored in that area variable, the 300. So this is what makes a value returning function useful. You can catch the value that is returned so that you could then use it in some future code. Okay, value returning functions are only useful if you catch the value that is returned. Otherwise, it's like playing catch with baseball, and somebody throws the ball over your head. You don't get to play with it anymore if you don't catch it, right? Same thing with the value returning function. And by the way, we've been using a value returning function for some time. We've used several, actually. We've used the input function. The input function is a value returning function. Think about how we use it. We go with something like this, right? Name equals input. Enter your name. Well, that's using the built-in input function, as this is provided for us by Guido and his friends. But this is actually the argument to the function when we use it. Whatever we put in the parentheses is the argument. In this case, it's a string, as you can see. Well, when we run this, whatever we type in gets assigned to this variable, doesn't it? So this is a value returning function. So we've been using them all along. So that's a quick overview of functions and value returning functions. But I'd like to use this in a program. Let's write a really quick program here. So I'm going to go actually to the script window, and we'll write an actual program that does something like this one. So why don't we try? We'll call it funcs_1.py. Don't think we have anything by that name. And what I'm going to do is I'm going to, as well as having my def main, I'm also going to have a couple more functions. So I've got my def main, but I want to define some custom functions here. So what I'll do is I'll define, not wanting to do the same thing over again, why don't I think about a cashier terminal? So how about, we'll call it cashier. And how does it work if you're buying something at a terminal, like say, actually this makes me think of like Home Depot or Walmart, where you can, you know, serve yourself, right? You can self-serve as you go out. Well, basically how this would work, the way a cashier station works is with the price and the quantity, right? In order to see how much an item is going to cost, I want to get the subtotal for an item. Well, I need to know the price and the quantity. And I want to make this a value returning function. So I would just say return price times quantity. I don't even have to create another variable. I can just use those. That's all I need, really. Now, if I wanted to find the tax on that, def sales tax, I guess we could call that. And I would need to know what the subtotal was in order to calculate the tax on something. So I'll call it subtotal. Now, in Pinellas County here, the tax rate is 7%. So I'm going to put that as 0.07. Notice I've capitalized that and used an underscore between the two words, tax rate. That's how you should work with a constant, all uppercase. So now I could calculate the tax. Tax equals that constant multiplied by that subtotal. Okay. And now I could return the tax. Now I could save the line. Instead of having this line, I could have just said return tax rate times subtotal, and I could have dispensed with having an extra variable in here. I think I will. It's probably a little more straightforward. So I'll put the return right here. Don't really need this variable. I'm not going to use it again. So I'll just leave it like that. So now I've got two value returning functions. Now I want to use this somehow in main to make a purchase. So I'm going to go up to main. And I'm going to ask the user to enter the price and the quantity. So we'll make it interactive. So we'll go with price. Now that's probably a float, right? So float input. Prices have dollars and cents in them, so they have decimal places. So we'll say enter the unit price, which would be the price of a unit. That means just price of one, obviously. And then we'll go with the quantity. You know what, though? I'm going to abbreviate that as just QTY. And the quantity, now the quantity might be an integer if we were buying like hammers or something. But if we were buying deli meat, it might be a number with decimal places in it, right? So I'm going to go with float on that one too. So I'll go with float input. And we'll say enter the quantity. Okay, now that I've got that, I should be able to calculate the subtotal, right? So I'll run the cashier function and I'll catch the value in a variable. So I'm going to call it, I'll just call it sub t equals, and I'm going to use that cashier function, cashier, and I'm going to give it the price and the quantity to work with internally. That should do it right there. That should, when Python reads this line here, it's going to say, oh, there must be a function called cashier somewhere in this file. It'll find it down here and it'll run this code here, letting the price go into this variable and QTY will go into this variable. Doesn't matter that I've got them with different names. I could have used the same name too, but we don't have to. So now that I've got that, I could also find the tax, right? Because to find the tax, I need to know what the subtotal is. So let's see, I should be able to find the tax. Tax equals, I'll run the sales tax function, sales tax, and I'll give it the subtotal to work with, which in my case is called sub T. See, the variable that's storing my subtotal is sub T. So I'll put that variable in here. So now I've calculated both the subtotal and the sales tax. So I should be able to print those out. Let's try it. So we'll try print, and we'll go with F strings here, and we'll kind of make it like a bill would look like a bill of sale might look. So we'll go with subtotal first, and I'll put a $sign in, and we'll go with our placeholder. And of course, we want to display it with 2 decimal places. So I'll put this SUBT variable here and 0.2F. I'll assume we're not getting into the thousands here. So we'll just go with, we're not buying vehicles. We're just buying groceries or something. So we'll go with 0.2F. And now I want to also print out the sales tax using an F string. So we'll go with sales tax, a $sign placeholder, close our string, close our parentheses, and here we'll put our tax variable, which we also want to format with 2 decimal places. So that would be 0.2F. And now we want to probably add those together for the total. So what we could do, I could have done this up above, but I'll do it right here. Total equals subtotal plus tax, right? And now I could print out the total. And we could do it as, we could say, please pay. So instead of total, we could say, please pay $, and our placeholder. And what we put here is our total variable. And we would format that with 0.2F as well for 2 decimal places. Now to make that run, of course, we got to put main down at the bottom of our code. We want that main function to run like that. Like that. Okay, so let's give this a try. Now I want to save it right away. Well, I guess when I run it, I'll save it right now. It hasn't been saved yet. But this is an interactive program that's using 2 value returning functions. Let's hope it works. I hope I haven't made a mistake here because we're running out of time. So I'm going to save it on my desktop, and I'm going to call it, what was it, cashier? No, funcs1. I forget what it was called. Oh, I got to cancel here. Yeah, it was funcs1. Sorry. So on my desktop, and I'm going to call it funcs_1. And run it. And I want a new window. Let's try a new window, fresh window. Okay, so the unit price, let's say it's, let's make this real easy, just so we can check the math. 250, and I'm gonna get 4 of them. So that would be $10, and the tax on $10 would be 70 cents for a total of 1070. So it's working just fine. Okay, so that's an introduction to functions, but they're tricky. Okay, it takes a little while to get used to them, particularly the fact that you got to catch the return value over here. And both of these functions were value returning functions. Value returning functions have the return statement inside, but we will look at some void functions as well next week. So we're in no rush to go through this chapter because we want to spend a little bit extra time here. It's time well spent. Okay, I hope you're okay. Any questions about this one at all? See how it's running? We've defined some functions. Anybody have a question?
I have a question, sir.
Yeah, go ahead, Dale.
Is there a limit to the amount of parameters you can have when defining the function?
I'm not aware of it. It could be. If so, it's really high,
Okay,
like hundreds for sure. I'm not aware of it. You could Google that, I'm sure.
Okay.
Yeah.
thank you.
I mean, sometimes you might need 5 or 6 or more, definitely. Any other questions about this one?
Should the definitions always be at the bottom?
Not necessarily. The way Python reads your file, it reads the whole file first, right? Looking for syntax errors and so on, and it also notes the name of any functions that might be here, so that when we go to use the function up here, when, for example, when Python reads this line, it knows that there's a sales tax function that it can execute down here. And that's actually what happens as the program, your program reads line by line, right? So this line does your input, this line does an input. But when it gets to this line, the program jumps down here to figure out what to do, down to this line here. Okay, well, we're over time here. I'm sorry, folks. Have a great day and keep enjoying Python. I will send you a link to this recording and all the files that we used today. I will attach those as well. Remember, I've got office hours tomorrow, 8 o'clock, Wednesday, 8 o'clock in the evening, Wednesday morning at 10 a.m., Sunday at 1:30 p.m. But I'm also available to help you outside of office hours, as long as it doesn't conflict with other classes I have or with your working situation. So if you've got an urgent need, send me an email and give me a time window when you're available, and maybe I'll be available as well, and we can do a Zoom together. Okay, so don't suffer away, right? If you have a problem, get in touch with me. And for help with your programming problems, I suggest you consult me instead of a tutor, because I'm the guy that grades your stuff. Makes sense to get me to help you. Alrighty, have a great day and be safe out there.
Thanks, Professor.
Logging off now. Take care. Thank you. Bye-bye.